Let's talk about impulse. Impulse is the effect of a force over a period of time. And when we talk about impulse, usually we're talking about a collision between two objects. So, if we're talking about force versus time, and we have a large force exerted over a short period of time, the area under that curve, so the area under curve is equal to impulse, which is the symbol J. So our equation for impulse, J, is equal to force times delta T. So if we're trying to find the impulse or the area under a curve, a lot of times we'll talk about the average. So we'll kind of split our curve in half and bring these two edges down so that it ends up making a nice rectangle. So let me make that a different color. So our average force then times that change in time, so we would end up making our change in time bigger, but our force, our max force, smaller, to calculate impulse, or J. So impulse, the units of impulse are newtons times seconds, or kilogram meter per second squared times seconds, which is equal to kilogram meter per second. Now let's talk about a theory called the impulse momentum theory. So let me delete a bunch of this stuff here. So the impulse momentum theory. And the impulse momentum theory says, that the effect of an impulsive force depends on the impulse delivered to the object. So that means that when a hockey stick hits a puck, the impulsive force that the puck feels depends on the impulse delivered by the stick. So, if we're talking about that same stick and hockey puck, then we would say that the average of acceleration of the puck during the time, so here's our hockey puck, and here's our hockey stick. This is a horrible drawing, but just go with it. The average acceleration that the puck feels when the stick is in contact with it is equal to the average force over mass. So we could change that into, or actually we know that the average acceleration of any object is just the change in velocity over the change in time. Therefore, that's also equal to the final velocity minus the initial velocity over the change in time. So we can set this equation equal to this one. And if we did that, actually, we would have to say that the average force over mass is equal to the final velocity minus the initial velocity over the change in time. And we know that the average force multiplied by the change in time, remember this is impulse, or J, is equal to mass times the final velocity minus mass times the initial velocity. So I just rearranged this equation to get this down here, algebraically. Multiplied out the mass. Before it looked like this, v final minus v initial. But I just multiplied out the mass. So this is saying that impulse is equal to the change in mass times final velocity minus mass times initial velocity. That means that impulse is the change in momentum, because momentum, P, this is momentum, is equal to mass times velocity. And velocity is a vector, therefore momentum is a vector as well. So to rewrite our previous equation, that would be saying that J, our impulse, is equal to our change in momentum. So the mass of the object affects the object's momentum as well as the velocity of the object, and both mass and velocity affect the impulse that an object feels. The change in the velocity over a period of... Sorry to re-say that, I was kind of mixing it up there. Our impulse, the average force times the change in time, is equal to the change in momentum of an object. And that brings us to the law of conservation of momentum. So the law of conservation of momentum. And this law just says that the change in momentum of a system is equal to the change of the momentum of one object plus the change of the momentum of another object plus the change of the momentum of another object, so on and so forth. So the law of conservation of momentum is just saying that the momentum of objects before they interact has to be the same as the total momentum of the system. So if we have two different spheres that collide, the momentum that they have before they collide has to be the same momentum that the total system has after they collide.